The Habitable Zone by Theron Krapek. Today I'm going to talk about the Habitable Zone, like what it is and how does it affect life around stars. I'm also going to talk about how we use it and what we've discovered. And finally, I'm going to talk about the exceptions to this zone. The Habitable Zone is a zone around a star that ranges from 273 Kelvin to 373 Kelvin, the temperature at which water is in its liquid form. This is important because water is essential to life, but not always. We'll learn about that later. Luminosity, or albedo, also affects how a planet is affected by its star, due to the ability to reflect light. The habitable zone around our Sun is estimated to be from 0.725 AU to 3.0 AU, and this zone is usually called the Goldilocks zone. This is important to us because it allows us to develop to the planet we are today. The habitable zone of other stars varies depending on its size, or mass. The more massive the star, the more far out and the larger the habitable zone is. The red dwarf pictured is Gilles 581, a star that has a habitable zone of 0.1 AU from its surface. The picture here shows what other stars' habitable zones look like and how they compare to Earth. The habitable zone effects. The habitable zone affects how a planet changes over time. During this time, it could have various surface temperatures due to the adverse effects on its albedo, such as clouds covering the planet. If a planet stays in its habitable zone of its star with the right resources, could begin to harbor life. Stellar evolution. This process defines how a star ages from beginning to cataclysmic end. As a star uses up its initial supply of hydrogen, it begins to expand and begins to use up its helium shell. This causes thermonuclear explosions on the surface of a star. The picture outlines what our Sun could look like in a very distant future. Discoveries due to the habitable zone. A multitude of potential planets have been discovered due to the habitable zone. A couple of interesting ones are Kepler 186f and Gliese 667cc. Kepler 186f is a planet found by a NASA space telescope. It is an Earth-sized object in a Sun-like star's habitable zone. However, mass or composition is unknown. It is 500 light-years away, and NASA scientists say that it is a rocky planet. The URL above is a video about this planet's discovery and the makeup. On a side note, why do we search for Earth-sized objects? We do this because if we can find an object that matches what our planet is like, then we can better theorize if it could sustain life. This quote defines what I'm trying to say. Now, Gliese 667cc is an interesting planet because it's part of a tri-star system and is about 4.39 Earths in mass. It also shares its star's habitable zone with two other planets and is 22.7 light-years away. Exceptions to the habitable zone. There are a couple of ways the solar system can affect a planet's life capacity. One being the habitable zone, which helps you a lot, but also could be the habitable zone could never have life. Just look at the moon. It's too small to have a thicker atmosphere, and is not protected by solar radiation like Earth. Planets outside the habitable zone. However, the habitable zone isn't the only factor in a planetary's life. However, you have to look at the other ways an organism or species could live without the presence of water, or even oxygen. Just look at Titan. It's outside the habitable zone, but it contains methane rain and rivers. It even has a thick atmosphere, covering the entire surface. But in the end, it's still just too cold, with a surface temperature of 97.3 Kelvin. Well, this wraps up my presentation. Thank you for watching.